we're going to look at conjugates. Now we have conjugates in a whole bunch of different areas that we can look at. Okay? Conjugates are with our binomials. Remember, binomials means that there's two terms. Okay? And what happens is that they just have the opposite sign in the middle. Okay? So we can have conjugates for our polynomials, for radicals, and even for our complex numbers. Okay? So notice if we look here, we have 3 plus 2 root 3 goes with 3 minus 2 root 3. Negative root 5 plus root 7 goes with negative 5 minus root 7. So notice this was a plus, this was a minus. This was a plus, this was a minus. Notice here on the second one that the negative 5 remains the same. It's only the sign in the middle that you're changing. So if we look at polynomials, right, these were radicals. So if we look at polynomials, if I have x plus 4, the conjugate would be x minus 4. Again, we have the plus in the middle goes to a minus. The minus in the middle, oh, I did this one wrong. Put this as a plus. That's my error. Sorry. Okay. The minus goes to a plus. The plus goes to a minus. So it's really just the opposite sign in the middle. All the rest of the signs stay the same. This was negative, this was negative. Positive, positive, negative, negative. Right? Okay. Now you can also have it where you've got I guess I should verbally say the ones here. So this we had with our complex numbers. So 2 minus 6i and 2 plus 6i. We can also have it where it's just part of it. So here we don't have a number plus a radical, we just have the radical part. So the conjugate for root 14 would be negative root 14. The conjugate for 3i would be negative 3i. The conjugate for negative 20i root 5 would be 20i root 5. And so on and so forth. So it's really, you're just changing the sign, because all of these are really 0 plus or 0 minus, 0 plus, 0 minus, 0 plus, 0 minus, right? So all you're doing is you're changing this middle sign, which is plus negative, plus negative, plus negative. Right? So then it changed it to negative, positive, negative, positive, negative, positive. Now, what's great about conjugates is that when we multiply them, things disappear, which is wonderful, and that's what we want. Okay? So here, if we multiply our two conjugates, what happens is that this number becomes squared. We square the number outside the radical, and then root c times root c is just c. Right? So these middle terms, or the o and the I of FOIL, this is the same as this, but they're opposite signs. It's kind of like in this problem that we just did the other day. Notice here we had negative 15 root 2 and positive 15 root 2. Notice these are conjugates of each other. So this went to nothing root 2. Okay? So that's what's really nice about our conjugates. And the same thing happens whether you're doing it with radicals, whether you're doing it with complex numbers, or whether you're doing it with polynomials. Okay? So if we look here, if we do x minus 3 times x plus 3, we can do x times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x. And then we can do negative 3 times positive 3 is negative 9. Well, these two things go to 0, so we get x squared minus 9. So this is our final answer. If we look at our next one, we've got, I'll do this one in a box. We've got 4 plus 2 root 5 and 4 minus 2 root 5. So we've got 4 times 4 is 16. If we do the 4 times the 2 root 5, the 4 times the 2 multiply to 8, and then we keep the root 5. On this one we do the negative 2 root 5 times 4, so we do the negative 2 times the 4 is negative 8, and then keep the root. And then we do where we've got the negative 2 root 5 times by the 2 root 5, so we multiply the negative 2 times 2, which is negative 4. Root 5 times root 5 is just 5, or if you take the pair out and it goes outside, so we have 4 times 5. So then this simplifies to 16 plus 8 root 5 minus 8 root 5, and then we have the negative 4 times the 5, which is minus 20. Well, these two simplify to nothing root 5, right, which is really just nothing. So then we have the 16 and the negative 20 that are like terms. So then that gives us negative 4 plus 0 root 5, which is really just negative 4. So that is that one. If we look at this next one, it's saying multiply the number by its conjugate. So if we take this one, we first have to determine the conjugate. So the conjugate is the opposite sign in the middle. So that means that I'm doing -2 minus 5 root 3, that's our original one, and I'm going to times it by its conjugate. So that means the sign of opposite in the middle. So I'm going to change the -5 to the opposite sign, which is positive 5 root 3. Okay. Since we did the box last time, we'll do foiling. So -2 times -2 is positive 4. If we do -2 times 2 root, or okay, let's try again. -2 times 5 root 3, we do -2 times 5 is -10, then the root 3. -5 times -5 root 3 times -2 is positive 10 root 3. And then we do the -5 root 3 times the 5 root 3. So that gives us -25, and then root 3 times root 3 is just 3. So then we're really doing the -25 times 3, which is -75. And then notice these disappear, which is what happens with conjugates, right? So they go to nothing. And then we've got the 4 and the -75 that end up being like terms. So this goes to 0 root 3, which we don't care to write anymore. And then we do 4 minus 75, which gives us -71. So that's how our conjugates work.